this thing off the ground here. He's so much credit for this exhibit coming to Petaluma. Joe Noriel, the president of the museum.
Well, once again for Jim Ocean, let's give him a hand. Well, welcome everybody. So happy to see you all. Sorry for the tight quarters. We actually intended to have this out in the garden court, but with the weather it didn't prove possible, so I do apologize that everybody's cramped in, but at least we're all nice and cozy. Obviously a very special day for the Petaluma Museum to honor the Beyond exhibit, and also a special day for Petaluma in general. And a very special guest, a couple of them today. And with that, I'd like to introduce Mayor David Glass.
Thank you, Joe. I want to congratulate Joe and the folks with the library for putting together a great speaker series, and I don't think anything will top today. This is just fantastic to have the guest that is here today. I know that Councilmember Mike Harris is here. Thank you, Councilmember, for being here. I don't know if other council members are here or not because the crowd is so big, and I came early and the people just kept coming in and in and in. So if I miss introducing any other council members, I'll catch you on the rebound next time. But thank you, Mike Harris, for being here today. This is a tremendous day here in the city of Petaluma, and our guest lives just down the road, so it's great to have a local person here to celebrate that on May 25th of 1961, President John F. Kennedy announced his support for the Apollo program during a special address to the joint session of Congress and said, "I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning safely to the Earth. No single space project in this period will be more impressive to mankind or more important in the long-range exploration of space, and none will be more difficult or expensive to accomplish." And whereas on March 3rd, 1969, Apollo 9 astronaut Rusty Schweickart, along with James Mcdivitt and David Scott, were launched into space on a Saturn V rocket to fulfill their mission in America's race to the moon. And during that flight, Russell Schweickart served as a lunar model pilot for Apollo 9, logging 241 hours in space. During a 46-minute EVA, Schweickart tested the portable life support backpack, which was subsequently used on the lunar surface explorations. Whereas the Apollo 9 crewmen spent 10 days in low Earth orbit, performing the first manned flight of the Lunar Module, the first docking and extraction of a lunar module, 2 spacewalks, and the first docking of 2 manned spacecraft, proving the Lunar Module worthy of manned spaceflight. And whereas Russell Schweickart was awarded the NASA Distinguished Service Medal and the Fédération Aéronautique Internationale de la Model for his Apollo flight, and also received the National Academy of Television Arts and Sciences Special Trustees Award, an Emmy, in 1969 for transmitting the first live TV pictures from space. And whereas the Petaluma Museum is hosting the exclusive California appearance of the Smithsonian Institution exhibition Beyond Visions of Planetary Landscapes to educate a younger generation on the importance of science and appreciation of space. Now, therefore, be it resolved that the Petaluma City Council does hereby designate Saturday, May 28th, 2011 as Russell L. Schweickart Day in the city of Petaluma, and thanks Russell Rusty Schweickart for his bravery and contribution to America's space program. Astronaut Schweickart.
Thank you.
Thank you.
All right, thank you. I'll put this. Okay, Mr. Mayor, Joe, Jim. Appreciate the introductions. In fact, the mayor's introduction was perfect. My God, we need, let's see, can people come in and get closer to the walls or something? No? All right. Well, you just have to use your long-range eyeballs. Sorry. Well, I'm really happy to be here today. A local neighbor came all the way over from Sonoma to be here. And today is
a special day, not because it's Russell Schweickart Day in Petaluma, which might get me a cup of coffee, but this is a time right at the very end of the U.S. Space Shuttle operations. It's a time when the Kennedy era is again remembered by a new book by John Logston, reflecting back on that early declaration. So it's a special time in history for us to reflect back on what happened and what that experience was. I'll say a few words about some of the things I'm doing now, but that will be very brief, and if you want to go further into that, we can handle that in Q&A at the end. But primarily what I'm going to try and share today is more the experience of flying in space, what that's like as a human being. Maybe I should back up because I'm looking right into the eyeball of the camera there. That may not be the best view. Okay, so this, of course, is a shot. We'll be seeing more of this as we go on, so let me just continue. The current interest that I've had for the last 10 years has been dealing with things that occasionally hit the Earth and go bump in the night. Sometimes they go bump in the daytime as well, but it's more dramatic at night. And these are asteroids which fly through space. They travel around the sun the same way we do. They're actually neighbors. But like neighbors, you know, from time to time you run into them. And these guys cross the orbit of the Earth every time they go around the sun. And every once in a while, we and they are in the middle of the intersection at the same time. And so we end up with things of this kind that occur. And 65 million years ago, an event of that kind, an impact by a near-Earth object or an asteroid, wiped out the dinosaurs and 70% of all life that existed on the Earth. It is the process of being able to predict these kinds of events that happen very occasionally, but when they do, they're terribly devastating, far more so than any other natural hazard, in spite of the fact that we've had lots of natural disasters lately. This would make all of those pale in comparison. The nice thing to know is that we can prevent this from happening. We can actually stop these things from hitting the Earth by knowing about them ahead of time and going up and changing their orbits very slightly. And that's the process I've been working on for the last 10 years. And as I say, we can talk about that later. For those of you who might want to look up something recent on that, the New Yorker magazine from February 28th of this year, and I'm sure it's available next door, has a feature article by Tad Friend called Vermin of the Sky, and that is an asteroid. Well, it's the work that we've been doing, and it's a very nice summary of that work and the people who have been working on it, and so I recommend that recent feature article in the New Yorker to you. But first, what I'm going to do before we get into any possible questions on that, I want to share with you, as I say, my experience in flying in space. Well, there are a number of kids here that were about my age when I got interested in this whole subject. In those days, there was Collier's magazine. Has that come back again? I've heard about it again recently, but I don't know if somebody's trying to resurrect it or not. But this is not the resurrected version. This was the original Collier's magazine back when I was a kid and in school, and I started reading about space. People like Wernher von Braun, Chesley Bonestell, and others began writing and drawing beautiful pictures and expressing their ideas about human beings actually going out and flying in space. And this was, of course, before anyone had seriously been working on that. And out of that experience, I was hooked on the idea of space flight, not just satellites, but human beings going out there. lo and behold, 30 years later or 20 years later, I was one. I joined the National Aeronautics and Space Administration back in 1963. In the third selection, as the mayor said, the third selection of astronauts that was made. In 1969, from the 3rd to the 13th of March, along with Jim Mcdivitt and Dave Scott, I flew the first lunar module. This was the first time that we had flown both the lunar module and the command and service module in space together. We used the big Saturn V rocket to get up, and we flew in Earth orbit to test the lunar module for the first time, rather than going out to the moon on the first flight. So I spent 10 days in orbit from the 3rd to the 13th of March. Again, the first flight of the lunar module, and it was the second flight of the big Saturn V launch vehicle. I'll step through a number of these pictures pretty rapidly. The other two guys still look pretty good. That's what I used to look like. Jim Mcdivitt here, our commander, Dave Scott, who was a command module pilot, and me on the left. I had red hair in those days. That was before I met Jerry Brown, for those of you who know I used to work for Jerry. Going outside for the first time with a backpack on, we had flown a backpack on the Gemini series, but the spacesuits were really quite primitive back then, and the mobility was very, very difficult. As a result, the spacewalks, or the EVAs as we call them, extravehicular activities, were really not very successful. And so I was the first person who was going to fly the new Apollo spacesuit, which was a much better design. It was much easier to move around in. And of course, running around on the surface of the moon, which my friends would do after my flight, we had to have a backpack that provided us all of the life support and communications and everything else. We couldn't be tied to the spacecraft itself with an umbilical. The difference between an umbilical, by the way, and a tether is that an umbilical provides life support, not just connecting you so you don't drift away. A tether is simply a rope. And on my EVA, my spacewalk, I had only a tether, and all of the life support was in the backpack. And of course we had to test that on the ground. This is a cage at the very bottom, and these are heater elements all around me here, which are simulating the heat from the sun. And this is all encased in a huge vacuum chamber, which is 10 times the height of this cage. It goes way up there. It's a huge vacuum chamber. And I'm in a vacuum as if it's in space with the heat from the sun, testing this backpack that I would use later on. Now, most people think that it's really dangerous when you get up into space and you go outside. Frankly, this is far more dangerous, much more dangerous. Why? Because not only is the suit newer, I mean, we hadn't tested it, this is some of the early testing, so the suit itself hadn't been tested that much, the same thing with the backpack, but the whole so all of the potential failures that you have in space are there, but the vacuum in space never fails. When you're in a big vacuum chamber, half of the problems that you're going to have that are going to kill you are failures of the vacuum chamber. And so this is ironically a far more dangerous operation than actually flying it in space. Now, this was the night before our launch. This is a traditional picture. The heavy water content in the Florida air, really makes the searchlights stand out bright at night. And of course, the next day, there you are on top of it, heading off into space, scaring the bejesus out of all the local birds. Now this is that same backpack and spacesuit that I was wearing earlier, but now we're in space with a reliable vacuum. And I'm outside the front of the lunar module. You just see a part of the lunar module here. This picture was taken by Dave Scott. And this is a handrail, I'll just point out here, that goes up the front of the lunar module and then across the top. And part of what I was doing, or would do later on in this extravehicular activity, was to go up that handrail and transfer externally over to the mothership or the command module to prove that we could do that in case the docking mechanism failed the next day when we separated the two spacecraft, went out for a rendezvous, and then came back together. And so this was a way of ensuring that even if the tunnel was crumped, we could still get back into the command module, because that was the only way you could get home. You couldn't come back to Earth with a lunar module. And this was a picture that I took looking the other direction. This is really one of the famous pictures out of the Apollo 9 mission. This is Dave Scott, who was a command module pilot. This is the command and service module here. And now you're looking at a different view of the front of the lunar module, again with the handrail going up here. And Dave is taking a picture of me while I'm taking a picture of him, which is a fun thing to do. And of course, you see the beautiful Earth below with the black, black sky. Here I'm partway up that handrail, right at the corner, just about to go around and over toward the command module. This is a picture after Jim Mcdivitt and I, the following day, got into the into the lunar module. We undocked from the command service module. And so anytime you see a picture of the command and service module in Earth orbit like this, it had to be from our mission, because we never had another mission where there were two vehicles during the Apollo program in Earth orbit together. This is, of course, a picture that Dave took of Jim Mcdivitt and I, the lunar module. You're looking down at the docking tunnel here in the middle. And here's the front porch that I was standing on, my feet attached to a thing called the golden slippers, where we could put our feet into these and let go with your hand, and your feet would keep you attached to the spacecraft. And of course you can see the 4 landing legs that we used later to land on the moon. So this was the test flight of the lunar module in Earth orbit. We tested everything that we could. This was just before Jim and I did a maneuver which put us 100 miles behind the command and service module in orbit, and from there we made a rendezvous and docking as if we had come up from the surface of the moon, which of course is what we did with the lunar module later on. Just to point out that the lunar module, for those of you who either weren't around at the time or who have forgotten since, the lunar module is composed of 2 stages. Pardon, it's upside down here, if you will, but this is the ascent stage where the crewmen are, and this is the only part that came back up off the moon. The descent stage here, with the landing legs and big fuel tanks and a big rocket in the middle, would stay on the lunar surface and be used as a launch platform for the crew to come back up and lift off the moon. So during our mission, we also tested that staging capability. And so here, when we came back after the rendezvous, you see only the ascent stage. And this is the front door, but the porch is now missing. And this is the engine buried in the middle of that ascent stage. So after, it took us about 8 hours to go out and execute this rendezvous and test all of the engines and controllability and all of that. After we tested the lunar module, the battery, it ran only on batteries. We didn't have fuel cells or anything of that kind. So once the batteries were exhausted after about 5 days, the rest of the 4 days of our, or the 5 days of our 10-day mission, I was more or less a passenger, and I took a lot of pictures out the window. This is actually a picture of a thunderstorm in the tropics down near the equator somewhere, and you don't have the very high winds at high altitude that you have here that cause an anvil top, you know, it blows the top off the top of these very tall thunderstorms. In the tropics you'll have very still air at high altitude, and so they come up and form just a perfect circle. It's like a mushroom coming up out of the clouds, and kind of unusual when you see it. For those of you who know, this is Cape Hatteras off the Carolina coast. Straits of Gibraltar and the Mediterranean and the Atlantic. So it was fun to have the 4 days of touring around the Earth while Dave was doing all of his work. I took a lot of pictures and enjoyed it. Of course, we came back to Earth those days before we had wheels and wings on parachutes. Luckily, 3 of them worked, and we landed in the ocean, didn't sink, and a helicopter picked us up. And this is the 3 of us getting out of the helicopter on the aircraft carrier. The other 2 guys, being military, knew that you have to salute when you come aboard a ship, but Dummy up there didn't realize that that's what they were doing. But at the same time, you can appreciate that you're a little bit scruffy after 10 days on a camping trip in space, tired and happy, the way you know, most of us are when we get done a camping trip. And by the way, looking forward to a shower and good food. So this takes me to the current program, and of course things have really evolved and changed a great deal since back there in 1969. Today, in fact today, as a matter of fact, the crew of the next to last shuttle mission are asleep now. They're about to wake up, in fact, and start doing their final packing before they undock from the International Space Station. The International Space Station operates today with a crew of 6 people generally. At the moment, there are 6 crewmen on the STS-1, the space shuttle, STS-134, that are about to leave. They've brought up the final piece of the International Space Station. So after, gosh, I don't know, what is it, 10 years of construction in space, the space station is finally entirely put together. There will be one more space shuttle mission in July of this year. That will bring up a lot of spare equipment and things of that kind, so that over the next 5 or 10 years, we'll have enough spares to replace things as they fail. But as of yesterday, we did the very last extravehicular activity that will be done out of the space shuttle. The crews from inside the space station will go out and do some more work EVA, but there will be no more EVAs from the shuttle, which has really been the construction wagon. You know, it's the thing which has brought up all of the rivets and, you know, the hammers and all of the pieces that we've put together to build this incredible Parthenon in space. What I did in going out for 47 minutes on my EVA pales in comparison. Today, well, yesterday, I think they did a 7 hour and 16 minute EVA, 2 of them assembling, and that was the 4th spacewalk or EVA on this particular mission. So without this capability of going outside in a spacesuit with life support and being able to maneuver and handle large pieces of equipment, this space station that's up there now, which is the brightest star in the sky, you can look it up on the web. If you can't figure out how to do that, ask your kids. They'll tell you exactly when the space station goes over next, and you can see it either very early in the morning sometimes or very early in the early evening, just after sunset. And the space station goes over on a regular basis, and it's really something to see it. It now holds people from many different countries who are up there. In fact, even the pieces of which it is comprised. These pieces over here are all from Japan. The robotic arms which are used to assemble this are made in Canada. So the Europeans, the Japanese, the Canadians, the Russians, and the Americans are all partners in the space station, and we have people who fly from many countries today. We speak English and Russian up there. And so those are the two primary languages that we use to communicate with the ground and with one another. And all of the astronauts today learn to speak Russian, and the Russian cosmonauts speak English. So this is an amazing thing. As I say, it's a Parthenon in the sky. It's a really historic vehicle which luckily we share internationally. Again, here's just a shot of the sort of typical EVA where people are adjusting equipment, assembling something, testing it, connecting or disconnecting cables, whether they're electrical cables or they contain liquid ammonia or something as a coolant. I mean, it's a tremendous amount of work that's done up there, and this whole thing would not be possible without the cleverness of human beings operating this equipment. Well, so in terms of a personal thing, what is it that stays with you after you've flown in space? I mean, I flew 43 years ago. I can hardly remember it. But the things that do stay with you are the two really unique issues, weightlessness, where everything is floating, and there's no way that you can do that down here. So it's a completely unique environment in space where everything is floating. Actually, everything is falling simultaneously, and you're falling continuously. You never hit the Earth because you're going around it, and the Earth is falling away as you are falling toward it. And so therefore you just keep going all the way around the Earth, and that's weightlessness. And you can see Jack Lousma here during one of the Skylab missions. This is a very, very large laboratory, not like the International Space Station where it's filled with equipment. This was a former liquid hydrogen tank that was the size of this room, or bigger actually than this room. And so there was a lot of room to experience weightlessness and tumble around and do acrobatics. And of course the other thing is the view out the window, and you're seeing not just the curved horizon, but you're seeing all of Egypt and the Sinai and the Red Sea. I mean, the scale of what you see is so tremendous, and you go around the Earth every hour and a half, and so you see the whole planet every hour and a half, time after time after time. And as I've said often to my wife, I went up in space where I left Earth and she was my true love. I came back down with a new mistress, which was the Earth. I mean, you really come to know the whole Earth. You appreciate the fact when you go around it in an hour and a half that this is a very, very special place in the universe. The sky is completely black. Everything that supports your life is there in that very thin blue band called the atmosphere, which is entirely below you. So it's a very special love affair that you end up with by the time you come back down. All right, so let's talk a little bit about weightlessness or gravity. The absence of gravity, or the fact that gravity is not the same as it is here on the surface of the Earth. I mean, there's no one in this room who, other than for just an instant, if you happen to jump off a tall building and didn't fly or something, you don't know what weightlessness is. And you certainly don't know what weightlessness is as a steady state where it's continuous. You don't feel as though you're falling. Falling is the change that you feel from standing or sitting or whatever to suddenly having something pulled out from under you. But when you're on something like the moon, as my friend Dave Scott here was on his, not on my mission where he and I flew together, but this was later on Apollo 15, and the Falcon, his spacecraft, his lunar module that he landed on the moon with. And Dave decided that he would try something because of two factors. Number one, he's on the moon, and so the gravity of the moon is only 1/6 of what it is here on the Earth, and things move or fall more slowly. And secondly, there's no atmosphere. And so Dave decided to test a hypothesis that Mr. Galileo came out with, which was that in a vacuum, all things fall at the same rate, no matter whether it's a hammer or a feather. And so Dave has a hammer in his right hand here, and in his left hand he has a falcon feather. Actually not from that falcon, but from a real falcon, that he took to the moon, and he decided to test this. Now, unfortunately, I don't have a speaker connected here, so I'm going to roll this film, and I'll just tell you what's going on if you can't hear it. I don't think you can. Okay, he's got a falcon feather in his left hand, and a hammer in his right hand.
We got here today was because of the gentleman named Galileo.
He says they got there because of a gentleman named Galileo.
About falling objects in gravity fields.
Right, falling objects fall together in gravity
A
fields.
better place to confirm his findings, so drop the two of them here, and hopefully they'll hit the ground at the same time.
I don't know if you can see that, but both the feather and the hammer hit the ground at the same time. So, lo and behold, Dave Scott proved that Galileo was right. And it's really fun. I mean, you can think of these things in space, and people do all sorts of things. I mean, one of the things that almost everybody does in flight when they get up there is you play with water. And this is actually a South Korean woman astronaut, and she's got a big bubble of water there. And people love M&Ms. M&Ms are great. You throw them up in the air, or you just let go of them, a handful of them, and then there's a yellow one and a green one and a brown one, and then you go around, acting like a fish and scooping up, M&Ms. And people throw, toss food back and forth. I mean, it's impossible not to play in weightlessness. I mean, it is so much fun to be in this environment where everything is floating, and you really enjoy it. So that's definitely one thing you remember very well. And of course, when you're not on the surface of the moon, but when you're actually in a big open volume like this is again Jack Lausma, and I'm sure many of you have seen on YouTube and other places, acrobatics in space, and you can do a quadruple gainer with 18 turns in it, and on and on. So it's just great fun to be falling up in space with everything else, and never having to worry about hitting anything, except when you get to the wall and your head is going first instead of your feet or whatever. So you have to be a little bit careful. But the sense of weightlessness. The thing which is so memorable about it in a way, and I think every astronaut has, and cosmonaut as well, has experienced this same surprise, and that is that even though you have not experienced humankind, everything, all life that we know of, evolved here on the surface of the Earth, in one gravity, in 1G, and yet here you are in this environment where you're experiencing weightlessness, and yet within a matter of hours, minutes even, you are completely comfortable with it. Now, I say that with some hesitation, because you may be barfing, okay? That's a different issue, okay? Your inner ear is not accustomed to it, and the crosstalk going on between what your eye sees and what your inner ear is telling you creates a lot of confusion in the brain, and for whatever reason, and there are lots of theories, but for whatever reason, the human or animal, mammal perhaps, reaction to that mixed signal is to barf. Now, it doesn't make much sense, but that's the reaction. And so about 40 to 50% of people who fly in space today get sick for the first day or 2 days or something like that. Now, we take different medicines, and Dramamine, blah, blah, blah. But it's not comfortable, and I can testify to that. But independent of whether you're barfing or not, and once you get done with that phase of adaptation, It is shocking how well, if you're going to go reach for something, you know, you reach it. If you want to throw something to somebody, you throw it to them. You don't have to compensate for gravity, you know, the fact it's going to arc or something like that. It's just amazing how rapidly you adapt. Now, that is best illustrated by a poem that was written by Joe Kerwin. Joe flew with Jack Lousma and Paul Weitz. No, actually, they didn't fly together. Joe was on an earlier Skylab mission before the one before Jack flew. And Joe and his wife Lee had a family tradition where for one or the other's birthday, the spouse would write a poem. And it happened that during Joe's Skylab mission in 1974, I think it was, Lee's birthday occurred while Joe was up in flight. And so Joe wrote a poem and sent it down over the communication loop. I happened to be in mission control that evening, and you know, we copied it down, and or actually we recorded the tape. And this was in the days, pardon me, kids won't remember this, but there were remember the reel-to-reel tapes, right? Well, this was you know, on a reel-to-reel tape, and so I said, well, I'm going home right past Kerwin's house, so I'll deliver it to Lee. And you know, head of flight control said, fine, that's a good idea. So I headed off and dropped in at Kerwin house, and Lee said, well, I'm not the best with, you know, trying to get these things to work. Would you mind stringing it on the tape recorder, or the tape player, the tape deck, so I could listen to it? And I said, fine. So I strung the tape on the tape deck and started to head for the door. And Lee said, no, just stay. You know, it might not work or something. And I said, well, you know, it's a little personal, isn't it? And Lee said, no, stay and listen. So I said, okay. And that poem that Joe wrote, in my mind, is I've tried to get him to publish it many, many times. He absolutely refuses to publish it, you know. So you're going to hear this once in your life. I hate to tell you. But it really captures this very, very human sense of, and even some of the implications of weightlessness and the personal experience. So Joe wrote this poem called "We're Getting Used to Knowing How to Fly." When I was young, I used to fly in ways up so high and easy, it would seem as if earth wheeled and slanted, and not I. And now it's real. Like dust motes in a sunbeam, push away, drift down your own trajectory, tumble, play, and who can tell which moves and which is still? In this high sunlit ship, the laws of space, height without vertigo, mass without weight, train our nerve waves in their easy pace as if this rhythm were our native state. What if man were in exile from the sky, and we remembering how to fly? Now that, I can't recite that poem or read it without getting goosebumps. I mean, that sense of almost having been there before, it is so natural, it is eerie. But that poem just literally captures that sense better than anything I know. And of course, as I say, it and this incredible view of our home planet, of the only planet that we know of, the only place that we know of yet in the universe that has life on it. And here we are, lucky enough to be on this incredible planet at the moment historically when Mother Earth, is giving birth into the cosmos for the first time. We are literally living at a historical moment of cosmic birth. And that is, in a philosophical sense, what we're all involved in. And regardless of whether the economy goes up or down, or what the budget is, or how much we're cutting, or who's going where, or whatever, in a historical sense, this is the moment in history when life is first emerging out of Earth and moving out into the cosmos, which is essentially infinite. And what else is out there, we have no idea, but we're headed out that way. So you guys are going to take the next steps, hopefully land on an asteroid, head on to Mars, whatever. But here's Mama Earth as we see it from space. Thank you. I'm happy to stand up here and answer questions for as long as you want to ask them. We don't have microphones out there, so shout loud because I've got old ears, but we may have to relay some questions. But why don't you go ahead with any questions, and we can talk about asteroids, we can talk about the experience of spaceflight, or you know, why NASA's got its head up its butt, or whatever. Yes, sir.
Do you miss flying up in space?
Do I miss flying up in space? I miss flying more than I miss flying in space, but you know, I also flew high-performance jet aircraft, fighter planes, and in some sense that's a little bit easier when you're flying in space. You know, it's going to take you a year to get ready for a flight, and you've got one flight, and then you're you know, you got another year or more to get ready for it. It's, of course, a unique experience, and some people have had as many as 7 flights. But I only flew one, probably, I would think, I have to check that, but I would think that something like 60% or more of the astronauts and cosmonauts have probably had only one flight. It's only a few that have had many, many flights. But in any event, it is something which is memorable, which can change your life. It certainly did mine. At the same time, like so many things, after you've done it for a while, after it has been done many, many times, it becomes much more routine. On Apollo, we were doing something brand new every time. I mean, it was really a big exploration. Now, one shuttle mission, superficially at least, looks very much like another shuttle mission. So, you know, I was in Romania about a week ago, 2 weeks ago, and I'm standing next to one of my cosmonaut friends, Doran Pranariu, in a setting very much like this. I mean, it was in a museum, as a matter of fact, in Bucharest, and this was a morning when they were introducing a new stamp for celebrating the 50th anniversary of human spaceflight and Doran's 30th anniversary of flight in space. And someone very much like the mayor was standing there, you know, reading a proclamation to Doran, and I'm standing next to Doran. He mentioned the International Space Station and how today things are a little more routine. And so I thought, yeah, that's really true. Things are more routine. So I leaned over to Doran and I gave him the elbow and I said, hey, Doran, how many people are in space right now? And here we are, an astronaut and a cosmonaut. And in fact, we got 3 other astronauts and cosmonauts standing off to the side of us. And not a one of us knew how many people were in space. I thought it was 4. Doran thought it was 6. Or thought it was 3. In fact, it was 6. You know, and then we tried to name somebody who was up there, and we could come up with one name. Okay, that was on. So, you know, the whole world would have stopped, and did stop when John Glenn went up, or when Yuri Gagarin went up, or whatever. So, I mean, these things change. Do I miss it? Yes, but I'd rather leave it to these young people. Yes, in the back.
Einstein said time changes when you're out of the gravity well.
Einstein, the question is, Einstein said time changes when you're out of the gravity well. No, he really didn't. What Einstein said was that when you're going near the speed of light, if your velocity is near the speed of light, then time dilates or time changes.
Do you have to keep track of that change when you're up there?
No. The speed with which you go around the Earth, anything that we've done in space is, on the speedometer of the speed of light, it's down on the peg, low. We've never gone fast enough to even move it off the peg, let alone get it up near the speed of light. But there's certainly no question that Einstein was correct. I mean, all you have to do is take any kind of a clock, and I'll give you an example of a clock. The decay of uranium or something like that, any kind of a radioactive material. If the decay time is something like, one atom splits maybe every second or something like that, if you accelerate those same atom, radioactive elements, and you get it near the speed of light, lo and behold, it splits, all the time. It thinks it's, as far as it's concerned, it's splitting at the same rate it did when it was sitting right next to you. But the fact that it's moving so fast with respect to you, when you look at it, it splits at a different rate. So we have many verifications. There's no question that there is this effect of the speed of light, and as you approach it, time changing, and the mass changing. I mean, that's a very interesting subject, and the kids will be studying that here, maybe when they get a little bit older.
I have a question.
Yeah.
On your generating your power, it looked like panels you had up there. Is that how you generate your power?
Okay, the question was that in looking at the pictures, it looks as though you were generating power. I'm just going to see if this will go back. It probably will. Yeah, it will. Okay, so we can go back. Oop. We can stop right there. Yeah, here are solar panels coming out the top of the telescope mount here, and another set of solar panels down here. You use a lot of electricity in space, and of course you have to generate it some way. And we generate electrical power in many different ways. Again, if I go back, we'll get back here. Okay, now there you see the solar panels on the space station, the International Space Station. And I should know, but I don't have the number, but that's, I think you're dealing with about 1.5 kilowatts of electrical power that you generate from these solar arrays. Now, from time to time, for example, on the command and service module in Apollo, we didn't have any solar panels. We used batteries. But batteries will run down, so we charged the batteries by having fuel cells on board, and we generated electricity using fuel cells. So you're going to generate electricity by whatever technology makes the most sense for your mission or for what you have to do. In this case, you're going to be in space for years at a time, not a few days or a few weeks, and so you've got to have some source of power which is continuous. And that allows you, you don't want to run out of fuel, if you will. So sunlight, of course, is streaming by you all the time, and using solar cells makes a lot of sense.
How did you get them up there? Did it go?
Oh yeah, everything that you see here was taken up piece at a time by the space shuttle and assembled together by the crew, EVA largely. So it's an impressive construction project. Let's take this gentleman here, or woman, I can't tell. Yes, yes.
Oh, can you explain what goes through your mind at liftoff and what it feels like?
Okay, so what goes through your mind at liftoff and what it feels like? Those are two very different questions. Let me talk about the physical first. And again, this varies from one program to another, but obviously I can only talk firsthand from the Apollo program. And there you're talking about this very large rocket, the largest rocket that's ever been built actually so far, Saturn V. And when you're sitting at the top end of it, you're a long way from the things that are making noise. But on the other hand, you know, right below those engines is the ground, and so even as you lift off, all of that sound is bouncing off the ground and then back up to you. You're not really hearing it directly. What you're hearing largely in a spacecraft is the sound reflecting off the ground and back up to the spacecraft at the very top end of that stack as it lifts off. And as a result, by the time you're 10 or 15 seconds into flight and you just get up past the launch tower, you know, your tail end gets up about 300, 400 feet in the air, and now the sound that gets reflected back up has been so dramatically reduced that you run into silence very rapidly. You can, while it's pretty loud and there's a lot of vibration right as you lift off, within 10 to 15 seconds, the sound is dropped almost to zero, and the ride is very, very smooth. Now that's not true with the space shuttle, because the space shuttle has solid rocket motors on the side and solid rocket motors instead of liquid rocket, which is what the Saturn V was. You have uneven burning. I mean, it's you know, it's a controlled firecracker, and so you get a lot more vibration on the space shuttle people launch today. But on the Saturn V, it was a very smooth ride until you run out of fuel on the first stage. And then all of a sudden, I mean, now let me get a little bit technical, not very technical, but you can imagine as you're going up, you're using fuel very, very rapidly. Okay, tons per second of fuel you're burning. The first stage has something like, on the Saturn V, 5 million pounds of fuel in it. The thrust of the engines on the bottom of the thing is 7 million pounds. And so it's pushing you up into the air. The engines don't change. They're still putting out 7 million pounds of force all the way up, but you're consuming 5 million pounds of force. So by the end, by the time you're running out of fuel, you weigh 5 million pounds less than you did at the ground. Well, let me tell you, you're getting a lot more acceleration when you still got 7 million pounds pushing on you and you weigh 5 million pounds less than you did to get off the ground. So the acceleration goes from just over 1 G up to about 7 or 8 Gs on the Saturn V. And so you're really pushed back into the seat as you get up toward the end of the first stage. Now, if you picture a tin can, I mean a long, tall tin can, but with thin walls, and you got 7 million pounds of force pushing on the back end of it, and you're up on the tip end of it, and now suddenly the thrust goes to zero, okay? All of a sudden that tin can gets longer, okay, because it's no longer being compressed by that 7 million pounds thrusting on it. And so suddenly you're way out on the end, and that end suddenly the whole tin can gets longer, and you go boink. And Dave Scott and I, to be a little more comfortable, loosened up our shoulder harnesses after the ground guys closed the hatches and couldn't do anything about it. So we loosened up our shoulder harnesses a little bit so that we could reach, the controls and switches and things, and if we had to abort, we could get out of the spacecraft a little bit faster. But when we hit burnout of the first stage, all of a sudden Dave and I went flying forward, and the instrument panel was here, and we kind of went we came within about 1 inch of the instrument panel before the shoulder harnesses caught us. And so as we sort of drift back toward the seat, Dave and I look at each other, and it's like, oh, that's why you don't loosen the shoulder harness. We'll have to tell the next crew. What do you feel, or what are you thinking? The main thing, different people think different things, and I didn't realize until many, many years later that some people actually experience fear. I mean, that was so far from my awareness, so you can't, it may be hard to believe, but you've been practicing and simulating for years and years and years, and the main thing that you're thinking is, finally the day is here. You know, and you may have, as often happens, had a few false launches where, you know, you're going to launch, but then something goes wrong and they have to postpone it, which also happened with us. So, you know, what's really going through your head is it finally going to happen? You know, is this finally going to be the day? And then it is. But yeah, let me get one right up front.
What are you doing now with these asteroids?
What am I doing now with these asteroids? Okay, well, that's about a 2.5-hour lecture if I make it short.
I'm here.
Yeah, you're here. Okay, well, let me just try to give a very, very short introduction to the asteroid issue. I mean, as I said at the very beginning, you know, asteroids have hit the Earth since the solar system was formed 4.5 billion years ago. And you know, 4.5 billion years got a lot of zeros. You don't really put this together in your lifetime, but if you live a really good long life, you got 2 zeros. And, you know, 4.5 billion years is, what, 9 zeros, I guess. So there's a lot of time, and even though we get hit very, very rarely, maybe once every several hundred years, the Earth gets hit by an asteroid that will do damage on the ground. If you divide, you know, 300 years into 4.5 billion years, the Earth has been hit millions and millions of times by asteroids, which would have wiped out a city if they had hit over a city. And if they get bigger, say the size of Petaluma, and hit the Earth, now you have something which wipes out most of life on Earth. And that's what happened 65 million years ago. When the dinosaurs and 70% or so of all life got wiped out at that time. Okay, so these things happen, and they continue to happen. I mean, you may think, in fact, people here, I'm sure, have in their head that I'm talking about dinosaurs. Well, that was way back in the beginning of you know, of the Earth. No, if the whole history of the Earth was 1 year long, and this is New Year's Eve, okay, at the end of that year, 65 million years ago was when? December 27th. Okay? So it just happened. I mean, that's recent. And those sorts of things happen about once every 100 million years. Ones of that scale. So it's probably not going to happen in our lifetime, but it may happen tomorrow. I mean, you know, it's all probability. Now, it turns out that, in fact, we can see asteroids. They go around the sun. They don't come in from way out in deep space and come in and hit the Earth. I mean, that's not the way things work. They orbit the sun. These are pieces of the solar system the same way as the Earth and Mars and Venus and everything else. It happens that there are millions of them. You know, the picture that you and I had when we went to elementary school, like these kids, was, well, we got, you know, a sun in the middle, and we got, when we grew up, 9 planets. I mean, we kicked Jupiter out of the gang, so we got 8 planets now, right? And then, you know, once in a while somebody would say, and in between Mars and Jupiter, you got the asteroid belt. You know, and you got these things going around in a circle, you know, between Mars and Jupiter. Well, that's just absolutely, totally wrong. That's like having a world without mosquitoes. I mean, you know, the real world, we got millions of these things going around the sun, and some of them, the ones we call near-Earth asteroids or near-Earth objects, their orbits cross the orbit of the Earth. Most of them are nicely behaved, and they're between Mars, their orbits are between Mars and Jupiter, and they don't bother anybody. But they get kicked out of that every once in a while by Jupiter, kind of a bully of the planetary system. And some of them end up in orbits that cross the orbit of the Earth. And all you have to do is picture a 3-dimensional intersection, okay, where their orbit crosses, one of their orbits crosses the Earth's orbit. And if all 3 dimensions are very close to 0, then if they're in the intersection and the Earth is in the intersection, that's called an impact. You know, it's just like 2 cars in the intersection of a couple of freeways. You know, if you're both in the middle of the intersection at the same time, it's called an accident. And that's what an impact by an asteroid is. It's the Earth and the asteroid being at the intersection at the same time. Now, luckily, unlike cars, the way you and I drive anyway, these things are very predictable. So that once you find them with a telescope, then you can predict their orbits. and you can predict them 100 years ahead of time. And so scientists today, astronomers, are finding these objects. We found 8,000 of them in the last 10 years. Okay, and you can predict, every time we find one, we predict its orbit 100 years ahead of time, and we ask that question: will it and the Earth be in intersection at the same time in the next 100 years? And 97.5% of the time, the answer is no. The other 2.5% of the time, the answer is maybe. Okay, because we don't have perfect measurements. And so we don't know exactly where it's going to be in 47 years. All right, we know approximately, we know where it could be. Okay, and if where it could be and the Earth intersect, then there is a potential for an impact. So we have to make more and more measurements, and you predict that. That's called the early warning system. You find these things, you predict where they're going to be, you know, for 100 years, and you say, is there going to be an impact? And if there is going to be one, or if the probability of one gets high enough that it's cost effective to do something about it, it turns out that even with today's technology, we can go up and change the orbit of an asteroid very, very slightly. Okay, these things are huge, some of them. You know, some of them are not. Some of them are small, like the size of this room. We get hit by ones the size of this room every year. Okay? They look like atomic bombs going off in the upper atmosphere. You have to be a little bit careful of that, but nevertheless, they come in all sizes. The small ones, many, many, many more of them than the big ones, right? So you predict these things ahead of time, and if you get 20 years of warning, then you can send a spacecraft up and you can very slightly change the orbit of an asteroid by running into it. There are several different ways, but we're not talking about a lot of expenditure for new technology. We're talking existing technology.
So are you a part of this program?
And that's a process that I and a number of people have been working on for 10 years to make sure that the predictions are done, that the telescopes get more powerful so that we can pick up more of the objects that can do damage, and that we test the capability to deflect them so that when we really get a threat, that we know, we have some confidence we can in fact do it, and people don't panic, but they'll say, okay, well, they know they can do it. The big question, and it's a boring issue, but it's the most important issue, is not early warning or deflection, which are technologies, basically, but the big question is, who makes the decision to do something? Okay? It costs several $100 million. Probably costs, by the time you really launch a mission, $1 billion to deflect an asteroid to avoid an impact. Whose money? Do we pay for stopping one hitting Zambia? Okay? Do the Russians pay? If one is going to be hitting in the Atlantic and we don't like that because of tsunami potential, well, we might go up and push it, you know, to the east. But the Europeans say, hey, wait a minute, you know, and they got a space program too, as do the Russians, you know, so they're going to race us up there and they're going to push it over us, you know. So how do you make those decisions, okay? That is the big issue, and we're going to end up getting hit because that issue we're going to be debating, you know, who does what, who pays for it, who handles the liability, you know, until the damn thing hits. What we've been trying to do, working in the United Nations for the last 5 years, is we've developed a decision process which we recommended to the United Nations. The United Nations has now taken ownership of that. They're bringing it to the General Assembly. It's a very slow, deliberate process. Hopefully all of that will get done before we end up with one with our address on it about to hit. Now that's a short lesson in asteroid, protecting the Earth from asteroid impacts. Yes, in the back with the blue shirt.
What's the scariest part of going up in space?
What's the scariest part of going up in space? Well, dying. I mean, you know, you can't get away from the fact that you're doing something that can kill you. But the fact of the matter is, if I ask you what's the scariest part about going home today, you wouldn't say that, but in fact that would be it, you know, if you end up in a car accident. But you know, you don't worry about it. You just get in the car and you try to be careful, right? But you know, that's the reality. Now, in terms of what are you thinking? Are you afraid? No. You know, it's surprising when you look at it. The reality is that the astronauts are laying on their back there in the spacecraft during the countdown, and sometimes those countdowns go for hours and hours and hours. And, you know, more than one of us have fallen asleep, laying on our back waiting to launch, you know. Me being one. I mean, it's, you know, it's a very nice little environment in that suit, you know, you're warm and comfortable and the air is going whoosh, you know. It's nice. But so, you know, it's not really scary. But, you know, anytime something goes wrong and you don't know what it was and you're not prepared to deal with it, that's scary. So the biggest thing that you do when you're an astronaut is you train for things going wrong. That's where 90% of your training, 10% of your training is when things are going right. 90% of it is things going wrong. And the guys out on the control panel who are running the simulation are devious. Okay? They're really twisted. And they're the ones who are always trying to throw something at you that you haven't thought about, right? To test whether you're ready for that to go wrong. And that's what the whole process of training is. So that by the time you've gone through 2 or 3 years of training for that, you know, you're pretty ready for it. And then right next to you, and then the gentleman here with the glasses. Yes.
A number of astronauts, including perhaps some of your peers, such as James Mcdivitt, Gordon Cooper, reported UFO spacecraft sightings while in outer space. I was wondering if you had any similar experiences, and or if you have any comments about that.
Okay, Nancy, note. My dear wife up here, raise your hand, Nancy. Okay, when I married Nancy, I was already, Nancy's number 2. So when Nancy and I got together 20-some years ago, I told her that this is a question which often comes up in these things. And she said, "Oh, you got to be kidding." And I said, "No, wait and see. This question always comes up." So I'm very happy that you asked this question today. And I am surprised to hear you say Mcdivitt. I mean, Gordon Cooper, yes. Mcdivitt, I'm really surprised if he said anything about UFOs. But
Including our places, including photographs you took.
yeah, and let me say, you're welcome to interpret those things or believe whatever you want. I never saw anything.
I'm curious if you saw anything.
No, I never saw anything that I would call a UFO in the sense that most people use it. If you're talking literally the words unidentified flying objects, every day I see something in the sky. I don't know what it is.
About 5% that may be from planets outside of this.
Yeah, well, again, there are all kinds of ideas. You know, the fundamental basis of anyone with a technical background or scientific background is evidence. And evidence, of course, is not exactly black and white, because what is evidence to one person can be BS to another person. So, you know, even evidence-based things require some very difficult judgment from time to time. I know people who feel that they did see what would be called a UFO in the classical sense. Gordon Cooper did, toward the end of his life, make some statements about that. Frankly, the rest of us looked at Gordo a little strangely. Gordo had some problems toward the end of his life in terms of mental stability, let me just put it that way. But there are many people who have had experiences which are very, very difficult to explain. And, you know, again, I've never seen anything. I've never seen anything that convinces me that it is. And logic tells me that it is not legitimate, in the sense that, you know, if you look at the, we don't know of any other planet that has life on it, number one. We are now discovering planets, which 10 years ago we couldn't even say that. But now, you know, we've seen about 12 or 1,300 potential stellar systems with planetary companions. So the likelihood, in my view, and here's where the thing gets very, very difficult, from a purely statistical basis, the fact is now we can say we have evidence with these planetary discoveries, we have evidence that planets are relatively common in the universe, with stellar systems. So the likelihood that we are the only planet in the universe that has life is ridiculously small. I mean, I can't believe that we're the only planet that has life. But there's no evidence that there is any other planet without life. But from a statistical point of view, I can't imagine that there isn't life elsewhere in the universe. Now, on the other hand, there are huge distances and tremendous expense to get anywhere. I mean, even in our own solar system, let alone going out to a star. So the likelihood that there is someone else who has sent something here to Earth to watch us or to look at us or to examine us or whatever the heck they're doing, or people are claiming they're doing, is to me an extremely, a vanishingly small probability of it being correct. But again, that's not evidence, that's belief. Now, I would hope that what most people do is look for evidence and not just form abstract beliefs, but you know, that's your call. The gentleman with the glasses, and then I'll get up here.
Two questions. One is, how were astronauts selected for one particular flight or another? And the second question is, what's the camaraderie or connection among astronauts, both across generations and across countries? Okay, well, good questions. The answer to the first one is pretty simple. You know, how are astronauts selected for a particular flight? The answer is the boss. You know, and it may be merit. It may be whoever is most friendly with the boss. I mean, you can have your own favorite theory, but basically the head of the astronaut office and generally the head of flight crew systems at Johnson Space Center selects the crews. Now that's not going to be true in the future. I mean, you know, we're going to end up with astronauts coming out of industry. You know, SpaceX is developing a launch capability and a spacecraft called the Dragon spacecraft, and they're going to basically lease it like a Hertz rental car or something to NASA to fly their stuff up there. But they're going to supply the pilot, you know, so it's no longer going to be just NASA. So, you know, where astronaut goes in the future in terms of definition and all of that is wide open. But when I flew, the boss selected. If you were a favorite of the boss, you got to fly a little more often than if you weren't a favorite of the boss. That's the way life is. Now, what was the second part? Camaraderie, yeah, okay. Well, I mean, like any group of people in a special category of that kind, you know, you tend to, I'm sure actors get together, you know, golfers certainly get together, you know, et cetera, et cetera. And astronauts and cosmonauts do the same thing. We have occasional reunions in Houston at the astronaut office, usually every other year. I started an organization called the Association of Space Explorers, which is our international organization, professional organization of astronauts and cosmonauts from around the world. We have 390 something or 400 and something members, all of whom have flown in space from 35 different countries. And we get together in an annual congress every year. You know, we drink together, we laugh together, etc. I mean, it's like any other group of that kind. So, and as a matter of fact, the work that we've done at the United Nations on the asteroid threat, the decision-making process, has been a product of work out of the Association of Space Explorers Committee on NEOs, which I chaired for years. And so let me get you, yes sir.
Was it hard to become an astronaut? Was it
hard to become an astronaut? No, it was very easy to become an astronaut. I filled out an application and I had all the requirements. You know, whenever you fill out an application, there's a bunch of things called prerequisites, which means you have to be under 5 feet.
You have to weigh more than 20 pounds. You have to be smart. I mean, whatever they may be. Okay, so you always have to meet these prerequisites in order to fill out an application. So filling out an application, when NASA announced it's going to select astronauts, you know, they have a list of things you had to be. And in my case, they were weighing education more highly at that selection, the third selection, than they were before. Before they were weighing being a test pilot very high. In my selection, you either had to be a test pilot or have 1,000 hours of high performance jet time, which I had, sort of. But I had more education than some of the guys who were test pilots. So we sort of compromised. So the secret in life, that you're going to find out, is be prepared. Like the old Boy Scout marching song. Be prepared. What that means is you never know what you want to be. So if you are really smart and you work hard and you get good grades and you put yourself in a position so that when something comes by and you say, oh, I want to do that, you can do it. And people will look at you and say, you're the person we want. And that's what happened. Yes, ma'am.
Buzz Aldrin wrote a book. Did any of the other astronauts write a book?
Many.
Oh, they have,
Yeah, many of them have. And some of them actually wrote it themselves. In fact, one of the best ones is Mike Collins' book, which he wrote himself, called Carrying the Fire. That's from the early days, but you know, many of them are as told to, or whatever. Okay, and some of them are very good. In fact, they're probably better than if the astronaut had written it. Yeah, let me get this woman here and then go here.
What is re-entry like?
Well, what is re-entry like? Good question. Let me give you a little picture of that because, and again, I can only talk about Apollo, and I'll answer it from the Apollo perspective. If you looked at the command module, I mean, it's a gumdrop shaped thing, right? It's got a big blunt heat shield, which at launch, you're laying, it's down, and you're laying on your back, three of you side by side, and the pointy end, okay, is the top of the gumdrop. So just picture a gumdrop. That's what it looks like. You're going to launch, you know, straight up with the pointy end headed up. But when you re-enter, you got to have the flat end headed in first, the blunt end. So number one, you're going to enter, that slows you down fast, and you got a heat shield there, which is going to protect you from the heat of the atmosphere as you hit it. So that blunt end is in the back of you, which means when you're coming in, you're going backward. Okay, now secondly, this spacecraft is not quite, it's symmetrical, but the center of gravity is a little off the center line. And so, in fact, you get a little bit of lift, you know, like wings, except you don't have any wings. But you get a little bit of lift, and generally speaking, you want to go further down range. And so, to do that, what you do is you're not just coming in backward, but you're coming in backward upside down. So when you enter, you're upside down, backward, looking back up at where you just came from, and your heat shield is behind you. And as you enter the atmosphere and the temperature gets higher and higher and higher, your heat shield starts burning off and turns into a plasma and ends up streaming behind you. And so what you're doing is you're upside down, going like a bat out of hell that way, and you're looking at your heat shield burning off and disappearing behind you. Okay? And as you roll back and forth in order to go a little bit right or a little bit left or land a little bit shorter, you're rolling back and forth. And so, in fact, what you're looking at when you look behind you is this bright, it's like being inside a neon tube that's whirling and swirling, and once in a while a chunk's going back, and you're thinking, ooh, I hope that heat shield's thick enough. Anyway, so that's landing then. Landing, well, let me go on, because as you get further into the atmosphere, you slow down now, and then you fire out some drogue chutes, which are very small parachutes, and they slow you down a little bit more until you're going almost straight down. And then the main parachutes come out, you blow off the drogue chutes, and the main parachutes blow out and fill up, and you know, you come down. Now, each one of those operations, all the way through, are handled by switches or by signals out of a computer, which is causing these things to happen, and almost every one of them is some kind of an explosive thing. It's a bolt that blows or a charge that fires or whatever, you know. And so as you're getting closer and closer to the ground, you're sort of counting backward, you know. There are 5 more things that have got to happen right for me to live through this thing. 4 more, 3 more, 2 more, and finally there's only 1 more thing that has to go right, you know. It happens and you say, yeah, it all worked, you know.
Really hot.
Yeah, no, your temperature didn't go up at all. I mean, the heat shield are very good. So, anyway, now today it's you know, it's a winged vehicle. I mean, the space shuttle at least comes down with wings. The Russian spacecraft comes down a lot like I just described, but with the space shuttle, that comes in, and now you want the blunt part forward, but the nose is pointy, so you crank it up, and the belly, you come in belly first. But it's the very same thing, and then as you get down deeper and deeper into the atmosphere, finally you slow down enough, and then you crank it over and you go pointy end first. Okay. Okay, let's take a couple more, and then we'll call the gentleman with glasses, and then the young lady with her hand up, or are you just yawning? No. Okay, so gentleman with the glasses first.
Is there a replica of the command module on the USS Hornet now in use?
Is there a replica, for people who didn't hear, is there a replica of the command module in the USS Hornet at Alameda? You know, I don't think so, but...
It's one of the Apollo command modules.
Oh, okay, there is a boilerplate there, yeah, apparently. And I'm sure that there are pictures, excuse me, there are pictures of it as well. Yeah.
Yours is in San Diego.
Yeah, if you want to see my spacecraft, it's down at the Space Museum in San Diego, by the way, the Apollo 9 command module. Yes, ma'am.
What kind of food?
What kind of food? Okay, well, you know, when you get old enough, you learn that it's not necessarily what it's called, it's what it tastes like. And so we had things which sounded great. I mean, you know, we had fruit cake, we had spaghetti and meat sauce, we had, you know, all kind of things that sounded terrific, but they don't taste like that. Number one, you're not feeling too good, at least I wasn't feeling too good for the first few days, so I didn't want to eat much at all. But then after I got over that and started getting hungry, you know, you eat some of these things and they don't taste like that at all. But if you think about it, it makes sense because, you know, your food had to be prepared months ahead of flight and packed and sent down to Florida to put in storage and then put in the spacecraft. And not only did it have to be cooked and packed and whatnot months ahead of time, but it has to pass vibration and shock and temperature extremes and everything else. And so you realize that when you write a set of specifications for the food, which are essentially identical for the specifications for a brick, your food tastes a heck of a lot like a brick, right? But if you want the closest analogy to it, if you go to a camping store, go to REI or somewhere and buy camping food that's rehydratable, that's, you know, you mix water in with it and you mush it up and then you eat it. Well, that's the closest thing that you can come to most space food. On Skylab, we actually had a freezer, so we had a little bit, about 10 to 15% of our food. I didn't fly Skylab, but I was a commander of the backup crew. On Skylab, we had vanilla ice cream, we had lobster Newburg, we had bread, things like that, but very little. That was like once a week you got a little bit of that. Okay, last question.
Oh, it's a good one.
I'll be the judge of that.
Well, since we're in the last days of the shuttle program now, can you kind of fill us in on the first 3 selections of astronaut groups? A little bit about the history and who was in it. And
in the first 3?
Yeah, you were part of the third group,
yeah.
You?
Okay, so I guess the question is, since it was a long time ago since I flew, who were part of the first three groups? Well, in the United States, the first three groups were so-called the original seven, which was, John Glenn, Alan Shepard, Gus Grissom, Wally Schirra, Gordon Cooper, I think I said Alan Shepard, but at any rate. And the second selection, which was made several years later, I think the second selection was 62, and that included people like Frank Borman, Jim Mcdivitt, Neil Armstrong, Elliot C., who was killed. I'm sure you never heard of Elliot, but Ed White, people like that. And then our third group included people like Alan Bean and Buzz Aldrin, Gene Cernan, myself, Dave Scott, others,
And the first group was in 58?
The first group of astronauts was selected in about
59.
59, was it? Yeah, I was in the Air Force, and I can still remember, articles in Life magazine about it at that time. But yeah, so 59, that makes sense. I can remember reading things in 58 about it, but the selection was probably 59. And I was selected. So when I came into the astronaut program, into the office, all of the prior astronauts were there, including John Glenn. He had not left the office at that time. So all of the first three groups of astronauts were, we were, half of this room, and, we knew each other very well.
So how many of them are living now?
How many of them are living?
John Glenn.
Half.
Half.
Something like that, yeah. Some of them have been killed, some of them just died, relatively ordinary deaths, but yeah, about half, I would say. It's at the point where you're counting. There's in the first group, I think there's only one left, isn't there? Is it just John? Is that right? No, Scott's still alive. Scott Carpenter is not doing well, but Scott's still kicking around. Okay, so there are two of the first seven. Okay, well, thank you all very much. I appreciate it. Enjoyed it.